Welcome. This is a recreation of our live session this morning where we went over chapter 4. So I will do my best to give you as much insight as humanly possible in here and adding things. If you have any questions after watching this video, please let me know and I'd be more than happy to answer them. So we're doing chapter 4, which is entity relationship modeling, and a lot of these things is going to be duplicated. So I'm going to go over some things that are extremely relevant. So please sit back and do the best that you can to follow along. These are the learning objectives. You can also get that from Canvas in there. I posted them as well in this chapter. And again, this is a review of the entity relationship model. Basically, it's a diagram that allows you to get a visual view of the entities, the attributes, and relationships. Now remember, entity is used in many aspects as a term. I prefer to use an entity as a table, but often entity is used as a single row in here. Attributes are the actual fields in a database. So you can use attributes or you can use fields, whatever you feel more comfortable. And relationships are common fields between two database tables. I also like to use what is called an entity instant and refer to that as a record or a row. So use whatever you feel most comfortable. I will try to stick with table, field, and record for that. And of course, relationships are basically the same term in here. And again, entity in this case refers to the entity set and not a single entity occurrence, which is actually a record or a row, depending upon what you're using here. So again, entity is a definition is an object of interest to the end user, such as a customer database in here. And then the entity relationship model refers to the entire entity set and not just the single entity occurrence. So it refers to a table, not a row again. So I give you a definition of attributes, which are required and optional. They're pretty self-explanatory. There are certain fields or attributes, depending on what you use. I'm going to use field. If I say field, please remember I mean attribute in here. There are certain things that you cannot leave out in a database when you're inserting a record, such as last name and field name. They are required. You cannot have a student without a name. However, they might not have a middle initial. Not everyone has one and might not be relevant. Same thing with email. Most everybody in this world has an email, but there's no guarantee that a student has a personal email and then a phone number in here. We all have phones, but not everybody wants to share their phone, or there are some people that just don't have phones. I don't know anybody, but we want to make that optional in here. And then, of course, an optional element is the ones that you don't have to put anything in there. Here is the different notation between gen and crow's feet. In this course, we're going to be using primarily crow's feet. I think it's a little bit more explicit in here. So you can see it just gives you the field names over here in the gen. However, in the crow's foot, you have bold entries in there. So I put a note in here that last name, student name, first name are bold entries. And they can, normally they mean that they are required. They could also mean that they are a primary key. However, if you go back into the crow's feet, you'll usually see a PK or an F key in for a primary key or a foreign key in here. An attribute, again, another definition, is a set of possible values for a given attribute. For instance, a phone number has to be numeric. You can't have ABC3. And yes, I know the old exchanges had that, so we have to take that into consideration. But however, a GPA can only be between 0 and 4. 4.0 is the highest and 0 is the lowest. And then an attribute can share a domain. Example is a student, a professor that have the same domain of all possible states in here. So, and we have identifiers, one or more attribute that can identify each instance. The entity can map to the primary key over here again. We talked about that before. Identifier normally is referred to as a key. So then we talk about primary keys. They're just basically definitions, one or more attributes. The key word here is uniquely identifies an instance or an entity instant or a record. For instance, student number 4212, there's only one student, 4212, and his last name is this, his first name is this, his GPA is this, his address, so on and so forth, all the same. And then, of course, they're going to be mapped to tables, and it's mapped to the primary key. Entities are mapped to tables. In ERD, the identifiers are underlined. And here's a new term, relational schema. Basically, it's just shorthand. So you have a table name, a key attribute. Notice the key attribute is bold and underlined, and then the rest of the attributes. And then car, you have the car VIN. And again, notice that the PK is bold and line. If you haven't figured it out, PK stands for primary key. A composite identifier is just basically one that is composed by a more than one vote. So ideally, you want it to be one attribute. But there are times that you need to have it where it's not going to provide the desired result, so you have to have one. For instance, a class may consist of the course code and the class section. You can't just do a course code because, for instance, in this class, IT 426, there could be 3 or 4 classes of this going on at the same time. So we can't use that as a primary key. And again, multi-valued attributes have many values, and I'll explain that in a little bit. So composite and simple attributes, again, and attributes are classified as either simple or composite, but don't be confusing them with a composite key. For instance, a composite attribute can be subdivided to yield additional attributes, such as address. We don't want to just put address in there. It would make sense to have city, state, zip in there, and of course the street. A phone can be broken down into the area code and the number itself. A simple attribute cannot be subdivided, such as age, sex, and marital status. Your age is a simple number. You're not going to break it down into years and months, although you could have separate fields if you wanted to do that. Sex, you're either male or female. Marital status, you're either single, divorced, widowed, or married. And then again, single value attribute has only one value. Again, a person can only have one social security number, period. And then keep in mind, a single value attribute is not necessarily simple attribute. Example, part number SE08, so on and so forth, is a single value, but it can consist of the region, the plant that made it, the part number, the shift when it was done. So it can be broken down into a bunch of different things. And again, multi-valued attributes have many values, and they require creating several new attributes. A new entity composed of original multiplied attribute components, and then again, attributes that have many values are, say, like cars owned or degrees owned. A single person can own 4 cars, and a single person can have a undergraduate degree and several graduate's degrees in here. So here's an example of a multiplied attribute in an entity. Notice that we have car color, and that's a simple thing. However, we think of a car color as blue, red, green, or whatever it is. However, what about if the top is different than the body, or the trim is something different? So here we have a multi-valued attribute broken down into new attributes in here, which makes more sense over here. And you could even have a separate entity for it, but it's just be easier to do it in S. A derived attribute is basically something that's calculated, such as the age or an invoice cost. So you do not have to store it in a database. There's pros and cons for doing each one. I have a table that shows the pros and cons for each one. So let's go with age. So it's derived from the date of birth and the current date. So you're either 1-year-old, 2-year-old, 3-year-old, 4-year-old, and here is the formula to do it. We're taking the current date and we're subtracting it from the date of birth, which gives you the actual number of days in there. And then you divide that by 365 to do that, and then you're creating an integer, so you don't have somebody that's 6.25 years old. And normally systems are, if you're 1 day shy of your 21st birthday, it considers you 20 on Tuesday and 21 on Wednesday. Again, the item cost is calculated through the item quantity and the actual individual cost, which give you a line item cost in there. And here we go again, the depiction of a derived attitude in here. So you have the employee age over here, you have the employee database. So in this particular case, the age is physically stored. Often in reports, it's calculated. Here are your advantages and disadvantages. Obviously, if it's stored, you don't have to calculate it. So it's going to save your CPU, save access time. But in reality, how long does it take to calculate somebody's age? However, if you're doing this for millions of records, it can be a little bit time consuming. If you don't store it, then it's obviously saves storage space in here. And then the computation is always going to yield a correct value. So for instance, if a person's date of birth was in the system wrong and you change the date of birth, it may not automatically recalculate that. So you have to take that in advantage. So that's the disadvantages, requires constant masons in here. And use CPU cycles, increases data access time. Again, CPUs are so powerful that it really is not an issue to do it. Again, there's no right way or wrong way to do it in here. So we're going to represent some entity attributes in here, the different ways of doing it. I prefer the third way over here. This is just simple an entity called item. This is an entity with the primary key. Notice it's bold and underlined. And here is the preferred way of doing it. So we have a primary key, an item ID in here, item, and then these are the actual attributes. This is the way that we need to do this. So again, we have entity classes. Entity is really easy. Just think of it as a recipe versus the actual case. So the entity class is just a description of the structure and the format. So again, we have a recipe, pound of flour, a cup of this, sugar, so on and so forth. And then the actual instance is the actual baked cake itself. Remember that each cake could have a little bit different ingredients in here. So here we have a item class. So we have item number, description, cost, and so on and so forth. So here, by the way, is a way where we could have a derived attribute by multiplying the cost times the list price in here. So in here. And then the quantity in hand would actually have to be calculated from whenever we do a sale, we have to recalculate those things in here. So you can see these are instances, and they're different. Relationships, very simple. It's just two instances of entities or two entities themselves that have bidirectional relationships, such as a customer table and an order table. Again, entities are the participants that participate in it. Connectivity describes the relationships, whether it's unary, binary, ternary. Cardinality gives you basically the values that are legal. For instance, an age, well, it's got to start at 0 because nobody is -1 age. And whether or not you want to end it at 100, that's, again, I don't know of anybody that's older than 200 years old. However, again, nothing surprises me anymore. So here we have it shown over here in crow's feet. However, again, these things over here don't show the actual fields itself, but we have a one-to-one relationship and a one-to-many. So this is one-to-one. That means each class, so we're going this way, can have one and only one professor. Now, bear in mind, this isn't always necessarily accurate because they may create a class and a teacher is not assigned. However, the importance of doing one-to-one is you can never have a class run without a physical teacher. So it's best to do one-to-one. If you put the 0 to 1, that means you can have a class without a professor and let it run. And however, each professor now can teach a minimum of 1 class and a maximum of 4. However, this again could be modified to 0 to 4, because maybe a professor is on research for a semester and he's not teaching any. So that would be 0 to 4. Again, you have to use that and take that in consideration and when you're creating the database, whether or not you're going to do that. Again, existence dependence and independence is pretty self-explanatory. I'll just read the definition. Entity exists in a database only when it is associated with another related entity occurrence. And I'll show you an example in the next slide. Independent, it means it can be created without being associated with another entity in here. This is referred to as a strong entity or a regular entity. The other is weak. So again, I will give you this here. An entity is an existent dependent when its only reason for being in the database is to be associated with another entity. It obviously has to have a mandatory foreign key, otherwise it cannot be associated with it. And the foreign key cannot be null. So here's an example, a college database with a student database. Well, if you have a student database and then one of the fields is a family contact in here, then you would have a contact database. And the reason why you would need that is it could have 3 or 4 different contacts in here. So as a result, you have to have a student for a contact to be associated with it. You just can't create a contact and it doesn't have a student to be associated with. Existent dependence in here is where you have something like parts, where you can have a part such as screws, such as cords, such as that maybe be assembled in here, but it's not associated with an actual product yet. So, and again, we have some of the parts are produced in-house, others are brought from vendors. So that's one example. And a relationship strength. Okay, very important. Weak relationship is basically the primary key of the related entity does not contain the primary key component of the entity. So basically, it's just plain foreign key, and you'll see an example of that in a minute. And by default, relationships are established by having the primary key of the parent entity appear as a foreign key. And notice the F key stands for foreign key. PK, of course, is going to stand for primary key. So here we have a course code and a class code. So we have here the class code is the primary key. The foreign key is course code, and it's related to the course code, the primary key in the course entity. And again, this one shows the thing over here. So you have a dotted line, which means it's a weak entity or non-identifying. So here's the foreign key, the course code, and it applies to the primary key of the course code in the course file. Relationship that's strong is going to have a part of the primary key is the primary key of the related table. So here you see we have course code in the course file, and the class we have the course code and we have the class section. So that means part of the foreign key is actually part of the primary key in the class file. So the next one will show you that in here. So we have a primary key and primary key. This is the course code and the class section. However, the course code is also a foreign key to the course code in the course file in here. So this is the way it's done. So we can have each class can only have one and only one course associated with it. Now notice that means 1 and 1. So here again, this class cannot be created without an actual course to identify it with. However, each course, you can create a course without creating an actual class section. And that's often the way it does. We're going to create courses, and then what we need to do is we need to create sections to go along with those courses. And of course, you have class time, room code, and professor num in here. So the professor num would be a foreign key to the actual professor classes. A weak entity, again, I'm going to read this to you and explain whatever is necessary. It's an entity whose instances cannot, again, we've already talked about this, is duplication without the existence of an instance of another entity. For instance, the class cannot exist without the course. The entity has a primary key, which is partially or totally derived from the parent entity of the relationship. So again, I've given you an example. An insurance policy ensures an employee and any dependents are included in the policy. However, what happens if the employee doesn't have any dependents? That's not a problem. However, you can't put dependents in here that are not associated with the employee. So in other words, an employee can get coverage without having a dependent, but a dependent cannot get coverage without an employee having coverage associated. So we have it in here. So here's a weak entity. The dependent is weak in here. And notice 0 to many. Now, N and M are basically the same in here. They just use a different notation in case you're going to use a many to many, which we're not going to use in this course. We will show you, but we're not going to actually physically use them. So basically, a dependent cannot exist without an employee in here. An employee can have a dependent without in here. That's where the 0 is in here to many. Now the cardinality is here, is 1 to 1 and 0 in here. So, and then here's how it's done in crow's feet. Notice again, foreign key, primary key, primary key. So we have employee number and dependent number is the actual primary key because you might have 5 different dependents. Employee number and the dependent number usually be 1, then employee number, of course, is going to be the same, and dependent number is 2. And again, here we have the cardinality in there. Strong entity can exist in the database. So again, it's called existence dependent. It has a primary key that's partially or totally derived from the parent entity in here. And again, the database design will determine whether or not to do it and what are the business rules. So here is both a strong and a weak entity example. The customer is a strong because you can create a customer without any orders. However, you have a weak entity because the orders here cannot exist without a physical customer in there. So again, this is a weak entity and a strong. Again, notice the dependents. So here's an example. So employee 101 has 2 dependents. Employee 108 has 3 dependents in here. So this is weak and this is strong. Relationship participation, again, it's either optional or mandatory. Remember, relationships are bidirectional. That means they operate in both directions. So if a course is related to a class, then of course a class is related to a course. And again, it's bidirectional because it's necessary to determine the connectivity of the relationships from both entities. And again, the minimum and maximum cardinalities should also be determined in each direction. So we have optional participation. One entity occurrence does not require a corresponding entity in a particular one, and mandatory, it does require it. I know we're saying a lot of the same things in here, but hopefully that will help you to fully understand that. So now we have our optional participation. One entity occurrence does not require a corresponding entity. And so I've given you an example. A course generates a class. It's possible to have a course without a class. Therefore, the class is considered optional. Uses crow's feet. You can use 0 or 0. Little o, 0. In here, it's done for you automatically. This is done in Visio. You can tell it's done in Visio because of these green little things that allow you to do that. You can also do the same thing in Access. Now we have crow's feet symbols, 0 to many, 1 to many, 1 to 1, and 0 to many. And again, a class is optional over here. Therefore, you see the 0. Mandatory participation, again, notice that that means you have to have at least 1. So the entity occurrence requires a corresponding entity occurrence in a particular relationship. If it's not optional, you can see that it's in here with the little 0. Example, an invoice header generates invoice items. You cannot have an invoice header without invoice line items. So therefore, the class entity considered optional proceeds one, and so on and so forth. So we kind of talked about two different things at the same time there. Again, same thing, course and class, mandatory relationship. If it's mandatory, it's going to say one. So a course generates a class. So in this particular case, the business rule says you can't have a course without creating a class. Again, the business rules are the ones that are going to determine whether or not you can choose that. So with that, I'm going to take a 30-second break. To give you a second to digest all this stuff. Okay, and we're back. Here we have the different relationship degree. Unary is a relationship that's in the same table, and that's recursive because they are reciprocal to the same table over here. Binary is 2 separate tables, and ternary is 3 separate tables. Now we have relationships here that be connected to each other in relationship. Again, degree 1, degree 2, and degree 3, unary, binary, and ternary. And here is the conceptual. And over here, an entity is related to itself. A person is married to another person. That person is married to that same person. Therefore, it's recursive and receptional. Here we have binary, we have employee, and then we have parking space. An employee does not necessarily have a parking space, but technically he would have a parking space. Again, business rules. But a parking space can exist without an employee being assigned to it. And then we have a ternary is a doctor, prescription, and a patient. The prescription is the go-between. A doctor writes a prescription. In the prescription, it has a physical patient and it has a drug. So again, a doctor writes a prescription, involves a patient and a drug in here. So you can see how this can be written in here. So we have a doctor, a patient, and a drug, and he prescribes it. So it's the doctor. So the prescription doesn't have to have a doctor, doesn't have to have a patient, doesn't have to have a drug. 0, in other words, the prescription itself, the actual prescription of some kind of medication, doesn't necessarily have to have a doctor assigned, but it's the actual prescription itself in here. So you can see how that works in here. So the doctor creates the prescription, and it has in here a patient, and it has in here a drug. So do not get too hung up on ternary relationships in here. So they're there for you to understand. In this class, we're probably not going to use them, but I want you to understand how they work. Another example over here. And then recursive relationships, which is right over here. It's unary. So an employee is married to another employee, or he manages an employee, or a course has another course in here. Let's just stick to the married to. So this person is married to 0, 1, because an employee doesn't necessarily have to be married in here. But the employee who's married to, so Joe is married to Sally, he can only be married to Sally. Sally can only be married to Joe. Therefore, they're recursive in here. And then we have associate composite entities in here. It's used, notice we have the M and an N for many to many. We're not going to use many to many relationships. We will breaking that up into a one to many and then many to one. And you can see this in here, converting a many to many relationship into 2 one to many relationships. So we had students and class, and we're using enroll in here to break that up in here. So this would be one to many. This would be one to many. And this is the conceptual view of it over here, much easier to understand. So a student doesn't necessarily have to enroll in class. Maybe he's taking a semester off. And then the cardinality would be 0 to 6 or 0 to 5 in here. And then the class could be created, but maybe nobody's enrolled in it. So basically, you're going to have the cardinality here of 0 to 30, 0 to 35, however many that's determined in here. So we have developing an ER diagram. Again, these are the way that you need to do this. You create a detailed narrative of the organization description in here. You identify business rules based upon the descriptions. You identify the main entities and relationships, and I actually have a slide, the very last slide that shows you how to do that. Then you develop the ERD, and of course you make changes. So you can identify the attributes, primary keys, foreign keys, and then just revise it as necessary. So here is an example of the tiny college in here. So what I'm going to do is I'm going to stop this right now, and I'm going to make a separate video of the tiny college. So right now we will stop, and I will let you look at this for a minute, and then I will add a separate video specifically for the tiny college, and it will explain the segments step by step. So looking forward to seeing you again. Hope this video helps.